So this will be the second half of the domain and range, I would say. And here what we'll be trying to do is we'll be using the equations that has been given to find out the domain. And when you're looking at the basic graph and reading the domain and range, it is much more easier. But when you have a specific graph given, let's say when you have a specific equation given, and you want to find out how does the domain and range look like for that question, that's where we're going to tackle such questions. So let's say if my equation is f of x is, let's say, root of 4 minus x squared, and we are asked to find out the domain and range for this kind of question. Now, generally, now when you talk about the 4 minus x squared graph, what we need to understand is that, let's say, 4 minus x squared must be positive number, because what we need to see is that square root of x graph is defined only for x greater than or equals to 0. So this is the square root x graph. So any square root graph is not defined for negative x values. So the limiting condition is that if you have any function inside the square root, it must be positive or 0. So now here, if I see, I get 4 minus x squared is greater than or equals to 0. Now, before I do this problem, I would do an easier one. Let's say I have to do square root of 3 minus 2x. Now, when I have square root of 3 minus 2x, let's say, now 3 minus 2x must be greater than or equals to 0 because of the uh, inside the root, it must be positive. If it is not positive, it will become imaginary number inside root. So if I have something like root of negative 4 is undefined. So that's why inside the root, it must be 0 or above. That's the condition. So we use that to find out the exact domain for this graph. So it will be 3 greater than or equals to 3 greater than or equals to 2x. And so if I divide both sides by 2, I get x is less than or equals to 3 over 2. So that's how you get the domain for this particular question. Now, when you talk about the second question out here, which is f of x is root of 4 minus x squared. Now, in this case, 4 minus x squared must be greater than or equals to 0. So now if 4 minus x, because inside the root it must be positive, so 4 minus x squared must be higher than or equals to 0. Now once again here you see is you get a quadratic inequality. Now lots of times what students make mistake is that they'll say, okay, negative x squared is greater than or equals to negative 4 and x squared greater than or equals to 4. Firstly, this is wrong. And they'll say, okay, x is greater than or equals to plus minus 2. Never do this, never do this, because this is going to be a big mistake. So what you do is, in this case, you try to basically find out the Sine diagram for 4 minus x squared. So what you do is you try to draw the Sine diagram for 4 minus x squared. So first thing what you do is you take the, let's say, the roots of this. So if I take 4 minus x squared equals to 0, I get x is plus or minus 2. So we get plus minus 2, so negative 2 and positive 2. So we got these two roots. And now if you sketch this graph, 4 minus x squared graph approximately is going to be something like this. It's a sad face quadratic. And in case if you don't know how to sketch quadratic, so what you can do is actually, let's first predict the domain and range using this quadratic that we have drawn. And next half is that if you don't know how to draw quadratic, which is a very rare case. So now in this case, if you see that I want this graph to be positive. So where is it above x-axis? So it is above x-axis in this range. So if you see that, so your correct answer here will be x between negative 2 and positive 2. So that's going to be the domain for this question. Now assume one case is where you don't know how to sketch the graph. So in that case, what do? We do is we create a typical Sine diagram. So pick up the values in each range. Let's say I pick up 0, for example, here, and plug in this. So 4 minus 0 is positive. It's coming positive 4. So I just write on positive here. If I pick up here, let's say 5, maybe 3 or something. So it'll be 4 minus 3 squared, which will be 4 minus 9, which is negative 5. So here it is going to be negative. Then beyond this, also it'll be negative. So for example, if I take negative 3, it'll be 4 minus negative 3 squared will be 4 plus 4 minus 9 again will be negative 5. Now, when you say positive, basically means that where is your graph positive? I mean, more than 0 means where is it positive? So it is positive between negative 2 and positive 2. So you can use any of the strategies to find out the domain for this. Now, as far as the domain for any particular questions which involves square root, when you get a general idea of that inside the square root it is greater than 0, that's where it is the beginning point. Lots of times students struggle because they don't know how to begin the problems. So let's take another example where you have to find out the domain of the functions under square root and all. So if you have x squared plus 3x plus 2, if I make it more than or equals to 0, that's what is the comment for the square root function. Now, if you draw the Sine diagram for this, find out the roots for this. If you factor it out, like x squared plus 2x plus x plus 2, by splitting the middle term, you get x is negative 1 or x is negative 2. So the Sine diagram will be negative 1, negative 2 here, and negative 1 here. And it's a happy face parabola. So it'll be positive, like it'll be a happy face graph like this. In between, you'll notice that this is negative. Here it is positive, and here it is positive. So if it is a happy face graph, that's how the graph look like. Now, when you find out the correct range of x values, where is it positive? Basically, you see that it is positive out here. It is positive in this range, so that you can say that your correct range of x value is x greater than or equals to negative 1 or x less than or equals to negative 2. So that's the domain for this particular question. While you're looking at the next one, my condition should be 4x squared minus 9 must be greater than or equals to 0. So I get is 4x squared minus 9 for solve for x, like you get x is plus or minus 3 over 2. So when I do plus or minus 3 over 2 here, so negative 3 over 2 here, and positive 3 over 2. The Sine diagram that you'll draw, it's like a happy face graph once again, like because coefficient x squared is positive. So here will be negative, positive, and positive. So you're basically drawing the Sine diagram for y values. So wherever the graph is above x-axis, that's positive. And wherever it's below x-axis, it's going to be negative. So you can see here it is negative between negative 3 over 2 and positive 3 over 2. So when you find out the final answer, then you find out the range of final answer that you need is basically this range, which is here. So correct answer for this one is going to be x greater than 3 over 2, greater than or equals to 3 over 2, or x less than or equals to negative 3 over 2. So that's the answer for this one. Now, in the third case, it is a little bit of situation where your denominator can't be 0 also. So where you include 0, if my entire stuff like 4 minus 9x squared, here it must be strictly more than 0. Because if you take 0, 1 upon 0 become undefined. So 4 minus 9x squared greater than 0. So if you find the roots of this, x is plus or minus 2 over 3. So let's say this is negative 2 over 3 here, positive 2 over 3. And now here coefficient x squared is negative. So it will be a sad face graph. So it'll be like something like this. So in this case, your Sine diagram here is positive. So it's positive, negative, and negative, because anything below x-axis is negative. Anything above x-axis is positive. So you want to see where it is positive. So that's happening between negative 2 over 3 and 2 over 3. That is this part of the graph where you can see it's positive, basically. That is this part. I mean, you can see this part is positive. So that's how you actually find out the domain for the square root functions. And now when you look at the domain for combined square roots, like there are two functions, how do we do for that particular function, the domain? Now in this case, you actually find out the domain of individual functions. Okay, so find out the domain of individual functions. So I'll take 2x minus x squared greater than or equals to 0, or it should be x squared minus 9 greater than or equals to 0. It's like now solving intersection of the inequalities. So first let's solve the individual of them, and then we're going to look at where they are. Both the inequalities are true. So now here what we do is, first we find out the factors of this. So 2x minus x squared is 0. So take x 2 minus x is 0. So I get x is 0 or x is 2. So when you take x is 0 or x is 2, you get this is 0 or this is 2. And in that case, what we get is this part is, it's a sad happy face graph. Sorry, sad face, because coefficient x squared is negative. So it'll be something like this. Now here it is positive, because you can see part of the graph is the x-axis. Here it is negative, and here it is negative. So when you talk about the final domain, final range for the x values here, it will be between 0 to 2, where it is positive. Next up is this one. So x squared minus 9 gives an equals to 0. So here you take the numbers, negative 3 and positive 3. X squared minus 9 equals to 0. When I do, I get x is plus or minus 3. So it's a happy phase graph. So it'll be something like this here, negative, positive, and positive. So my domain out here will be x greater than 3 or x less than negative 3. Now what you'll notice is that when I look at the graph, I need to see where both the domains coincide. And if they don't coincide, means this function won't be defined for any x value then. So let's say the first one is 0 to 2. So 0 to 2 is the first domain, which is this part basically. This part is 0 to 2. And then next part is x greater than 3. Greater than 3 is here, means this side. And x greater less than negative 3 is this side. So you can see that the graph is actually not overlapping at any point. So actually this domain, this function won't be defined for any x value. So if I say domain for this will be a null set. So this is the simple thing. Now in some questions where you'll see that there are overlap, for example, if my domain would have been like, overlapping, for example, it was something like this, let's say. Overlapping means the net function will be defined only between 0 and 2. So this is the only part that is coming as an intersection. This is not related to this problem. This in general we're talking. So let's take an example where you can see an overlap of the domains. So now, for example, let's say if my function is x squared minus 4, root of x squared minus 4 plus 1 over root of x squared minus 9. So now when I want to find out the domain for this combined function, once again, you take x squared minus 4 greater than 0, put the number line, negative 2, positive 2, happy face graph. Here it should be greater than equals to. So it is negative here, positive here, positive here. So x greater than or equals to 2 or x less than or equals to negative 2. That's the domain for this. Now in the second case, it is x squared minus 9 should be strictly greater than 0. So if I do the domain here, negative 3 and positive 3, here it will be negative, positive, and positive. So x greater than 3 or x less than or equals to negative 3. So that's your domain for this part. So now when you look at the main thing is the final answer is where they both are defined. So now look at the first domain is below 3, below negative 3. Let's say this negative 3 and this is above 3. And the second domain that you see is actually about 2, which is 2 is here. So about 2 and below negative 2. So this negative 2 is here, is below. So I see that both the functions or both the domains have the intersection around here. Beyond 3 onwards is the intersection. So both the function, when I combine them, they will be defined for basically the first one, I mean the combined function will be defined for x greater than or equals to 3, x greater than 3, not equals to, because this one does not have the inclusion of the values. So x greater than 3 or x less than negative 3. So this will be the resulting domain for this combined function. So what you're looking at is basically you're looking at where is the common intersection of the domains, which you can see clearly from here. So that's how you find out the domain and range for the square root functions, domain for the square root functions basically.